Hey folks, welcome to day 8, yes 8, of the Easter Maths Revision Pack. 3rd of April, Easter Saturday, let's go! Okay, so starting with the grade 5/6, we've got some factorising. We are looking for the biggest number that goes into both of these, which is 4. We are looking for any letters they have in common, which is M, and then anything we've missed out that would expand to that term. 4m bracket n minus 4m. Calculate the size of the largest angle in this trapezium. Okay, so what have we got here? We've got angles, we've got a 4-sided shape. So the rule we should be thinking about here is that the angles add up to 360 degrees. But we've already got like a 90 here and a 90 here, so what's more important is that these two angles here add up to 180, and that's a rule for trapeziums in general, because these are always parallel lines, and this is like a C angle, it's a supplementary. Supplementaries add up to 180. So we'll set up these two, which are 2x plus 60, equal to the 180 that we know they equal, and then we'll solve this. Once you've got the equation written down, it ain't too bad. X is 60. So what's the size of the largest angle? Well, you need to substitute that back in. If x is 60, then this is 110 at the top, and this is 70 at the bottom. Check they add up to 180, which they do. The largest angle is the 110 degrees. Cool. Okie doke. So here's a couple of words, you've just got to know what they mean. Front elevation means looking at a shape from the front. Plan elevation means looking at it from above. And when it says we want to draw a sketch of this shape, we need to draw a 3D sketch. The other word they could use is side view for looking at it from one side, obviously. So what's generally a good idea is to draw the front of the shape. Doesn't look like it's got anything too fiddly. And then you can see it's just, one square deep. So we'll extend it a little bit, and you've essentially got a little 3D trapezium, which is good because we just had one of those in the question above. Okay, shown as a shape made out of 5 pieces of metal, work out total length. So what is this? We want to know the lengths of these sides. This is clearly a 5, because we're assuming this is a rectangle. I guess they should really tell us that. But we need to find out this. How are we going to do that? Well, this is a triangle, this is a right angle, so this is Pythagoras. So x squared is 13 squared, take away 5 squared, which is 144, and square root that together, x is 12. So that gives us 12 on the top, 12 on the bottom, and then the question says total length of the 5 pieces of metal, so that includes the 13 going down the middle. So 5 and 12 and 5 and 12 and 13 equals 47 centimeters, because we've got units. Okie doke. And then lastly, we've got what looks like some reverse percentages. Okay, so you are given 102 DVDs. This is 70% more than what you had last month. So this means you know where you are now. You're trying to work out what you had. You're trying to go backwards. This is why it's reverse percentages. If we have 70% more than we had, then we're now at 170%. If we'd had 70% less, we'd be at 30%. So 170% is 102 DVDs. She's bought a lot of DVDs this month. How do we get to 100%? Well, we need to divide and times. I would recommend getting yourself to 10% by dividing by 17. Or you could divide by 170 to get yourself to 1%. And then times that by 10 to get to 100%. So that means she has 60 DVDs last month. Now you could check that works. If you add 70% onto 60, do you get back to 102? Yes, you do. If you go 1.7 times 60, that's 102. Another way of doing that question is 102 divided by 1.7, because that's the multiplier that would go with a 70% increase. But I prefer visualizing it this way. Okay, onwards to grade 7. A similar question. So we've had this before, haven't we? Where we look at lines and we know that the general format of any line is y equals mx plus c. That's what we're always trying to rearrange it to, where m gives you the gradient and c gives you the intercept. These are already basically arranged. So let's just do a quick stack table of what gradient and intercept is. We've got gradient of 2, got gradient of a half, gradient of 1, because it's just 1x. gradient of minus a half, and gradient of 1 again because it's 1x. It's not like the first number you see, it's the number in front of the x. The values of c, which are not really relevant to this question, but let's talk about them anyway, those are where they go through the y-axis. So which two lines are parallel? It's the two that have the same gradient. So it would be y equals x plus 1 and y equals 10 plus x. There we go. Which two lines are perpendicular? Well, perpendicular means the gradients are what we call negative reciprocals. That means you flip and you change the sign. So, for example, the negative reciprocal of 3 would be minus a third, and if one line had gradient 3 and one had gradient minus a third, they'd be perpendicular. So in this instance, the ones that are perpendicular are the 2 and the minus a half. Flip it, put a minus sign on it. So y equals 2x plus 1, and y equals minus a half x minus 3. Write down the equation of a line parallel to that passes through the point 110. So there are a couple of ways of doing this, but I am a big fan of the equation y minus y1 equals m brackets x minus x1 for finding the equation of a line. Parallel to this, which means we're going to use gradient is 2. And this is our point, so our x1 is 1 and our y1 is 10. So we can say y minus 10 is 2 brackets x minus 1. And you are kind of done at that stage, but I generally prefer to make it y equals. So expand the bracket and add the 10 across. There we go. You could check it works. If you sub in 1, do you get 10 out? 2 times 1 plus 8 is 10. Yes, you do. Job done. Keep going over that straight line stuff. It's really important for those sort of higher grades. Okay, convert into a mixed number. Now you might be able to see, I suppose, that this is 3 and a third, because you know that a third is 0.3333 recurring, etc. But let's talk about like how you do this otherwise, if you didn't know what it was. Because there's a way of doing this algebraically that you do need to know for like later sort of decimals. So the general way is to say, well, the thing I have got is 3.3333 ... and I'm going to multiply it up. I'm going to multiply it by 10 because there is only one repeating number. It's just 3, and then that repeats. If there was 2 repeating numbers, if it went like 373737, times by 100. That'll give me 33.3333 ... and then I can subtract one from the other, and I can get 9x equals 30. And then I can divide across, and I can say that this is 30 over 9. I can simplify that to be 10 over 3, just divide top and bottom by 3, and that is 3 and 1/3. So yeah, you can probably look at that number and see that it's 3 and a third, but the method that's important to know, as far as grade 7 is concerned, is how do you show that algebraically if you needed to. Right. Circle theorems again. There are 6 circle theorems. Do you know them all now? 1, 2, 3, 4, 5, 6. What have we got? Well, we've got the one that's going to be used here, which is double angle. We've got cyclic quadrilateral. Opposite sides add up to 180. We've got tangents and radiuses meet at right angles. We've got same segment, which is the fancy name for bow tie. We've got alternate segment, which is top left is bottom right, and bottom right is top left, and so on. And then we've got, this is a terrible circle. Oh yeah, the one I always forget is semicircles plus right angles. So, the one that's this one is obviously going to be double angle. We're trying to find ACB, which is up here, A to C to B. And the rule for double angle is that the angle at the center is double the angle at the circumference. So we need to divide by 2 and get that ACB is 56 degrees. Okay, this looks like a tree diagram, and I think it is. So what happens? Sharon chooses a counter at random, records it, and then replaces it. Okay, so we put it back, and then chooses a second counter. Yeah, this is a tree diagram. So what are your choices here? your first choice is the counter that you pick out first, which could be red, or it could be purple, or it could be white. The probabilities of those, there are 7 reds, 2 purples, 1 white, and there's 10 total. And then we could, if we wanted to, like draw the same thing again, and do like this, and have red, purple, white, and draw all the same stuff on. But you can be smart with tree diagrams. You can just draw the bits that you're interested in. And we're interested in the probability that both counters are the same colour. So if the first one was a red, we're only interested when the second one is also red. So we'd be interested in RR, PP, and WW, or double W. The probabilities don't change. Why don't they change? Because it said that they replace it in the back, they put it back. They sometimes use the word without replacement, which would mean that that probability is going to be different because there will now only be 9 counters left. And then to get the actual probabilities of each branch, you multiply along. So we go 7 tenths times 7 tenths. This is 49 out of 100. This is 4 out of 100. This is 1 out of 100. And then I want all of those added together, which is going to give me 54 out of 100, or 0.54 if you are more of a decimal person. No judgment here. Okie dokie. So, on to the tough stuff. Higher. Okay, right, so it doesn't start too bad. So, we do have this phrase here, giving your answer to 3 significant figures. And that is a big hint when it comes to a quadratic. So, quadratics, generally you're going to factorize or you're going to use the formula. And you use the formula when the answer is horrible. And if it says round your answer to significant figures, it's horrible, it's probably the quadratic formula. So let's use that. We could say that x is, so minus b would be 2, because you've got to change the sign, plus or minus the square root of minus 2 squared. Remember, if you're squaring a negative and you're putting it into your calculator, you need a bracket around it or your calculator gets all confused. Minus 4 times a, which is 5, times c, which is minus 11. So I think the only things that will really trip you up here, and 2a on the bottom, is getting your signs wrong. Now I prefer, if it's me, to simplify this bit inside the square root sign before I start doing stuff. So I know that this minus 2 squared is 4 because squares are always positive. This is going to be a plus because it's a minus times a minus, and 4 times 5 times 11 is 220. I think. Let me just check that. Yeah, 220. So that means that we can simplify this somewhat to 224 and then over 10, and then we can do our calculation. So when it's an add, we'll get 1.69666. Interesting number. And when it is a subtract, we'll get minus 1.29666. Curious. But the question says round your answers to 3 significant figures. Just bear in mind that's different from decimal places. There's our third sig fig, there's our third sig fig. And in both cases they're going to round up because there's a 6 after them. So actually to 3 significant figures it is 1.70 and minus 1.30. Okie doke. A little bit of compass stuff. Never eat shredded wheat, as I think my primary school teacher always used to say. Which means that they go north, east, south, west. Naughty elephants squirt water is of course the other one. Okay, so let's think about what we've got here. We've got B is 5 miles north of A. So let's draw this. Here's A. B is 5 miles above that. C is 7 miles east of B. So it's in this direction. That's 7. Find the distance A to C. That's this distance here. And we have ourselves a Pythagoras question that's just put in a wordy format. We're going to add for this one because we're trying to find the hypotenuse. So 5 squared and 7 squared, 74. And then square root it, and we'll get that x is 8.60. Let's go 3 sig figs. But then there's a follow-up. We want the bearing of A from C. Okay, and bearings is, I think, something we're a little bit less confident on. So let's draw the bits of the questions that are relevant, I suppose. From C to A. Now, what do we know? That means, so bearings are 3 digits, which we're going to come to at the end of this. They're from north, and they're clockwise. Those are like the 3 facts you need to know about what a bearing is. It's an angle that has those 3 things about it. This says from C, so we draw our north line at C, and we draw a line towards A, and we go clockwise from one line to the other. So that is the angle that we're trying to find. Now how are we going to find that? Well, we're going to have to use the rest of the triangle that we sort of drew before. So we know we've got 5 and 7, and we've got 8.6, but let's use exact values. If we can find this angle here, and we know that this is a 90-degree angle where it says C there, then we could take them away from 360 and that would give us the bearing. So it's like a SOHCAHTOA question basically. So what have we got? We have got an adjacent and we have got an opposite. So we're going to use TOA. And we're trying to find an angle, so we're going to go tan minus 1 of opposite over adjacent of 5 over 7. It's just going to give us 35.5, and then this is the actual angle we want. So our bearing is going to be 360, take away the 90, which is at C, take away the 35.5, which we just worked out, and that will give us what's left over. Or I guess you could have done 270, take away your answer straight away. And that will give us 234.46. But here's where the last bit comes in, it's 3 digits, so we just say 234 degrees for a bearing. That's even true if the number is something like 29.7, you would say 030. So it's just like the whole number part of the angle. Okay, 2 to go. Sketch the graph. Now, you could know this. This is an exponential graph, and you could know the shape of that. But if you didn't know it, you could try some points out. Now, I generally think when I've got to do something like this, I'll try some positive values and negative values and see what it does. So I'll try -5 and 0 and 5 and just see what sort of thing's happening. So 3 to the power of -5 is like 0.004. 3 to the power of 0 is 1. 3 to the power of 5 is 243. And what that tells you is it goes through the y-axis at 1. It never quite crosses the 0 line, and then it goes super big. And this is an exponential graph in general. If it said sketch 2 to the x or 10 to the x, they all look like this. They all go through the y-axis at 1, and none of them cross this line here. Okay, that is one of the shapes you're meant to know. And then finally, we've got some composite functions. Now remember, composites, you start from the right-hand side. So we start off with f of x, which is 3x minus 1. And then we are going to substitute this into g of x. So gf of x would be 2 lots of 3x minus 1 plus 4. That would be 6x minus 2 plus 4. That would be 6x plus 2. And that's it. That's grade 9 as far as the A-level GCSE is concerned, because it's a bit weird. You're just substituting a thing into another thing. Okay, folks, hope that helped. See you tomorrow for Easter Sunday. Cheers.